Hello and welcome to another jog vlog session. This one is going to be looking at river processes. So there's a lot of recap today with regards to the river processes that you're going to see and some of the coastal processes that you've already studied earlier on in this topic. And one of the reasons we use rivers rather than glaciated landscapes as our second option from those that are optional here is because there is that crossover, which means you have to learn a lot less in the process. So with regards to physical river processes, we are going to be looking at erosion, weathering, mass movement, transportation and deposition. So there's lots there, but because you've already done the groundwork really for a lot of these processes, but applied to coasts, it should hopefully mean that actually there's just more of a recap than anything else. So you can see from the learning objectives that there are 4 types of river erosion, and they are hydraulic action, abrasion, attrition, solution, or hydabatsol. There are 3 types of weathering that we need to be aware of when it comes to river processes, and they are mechanical, chemical and biological weathering. 2 types of mass movement that we're going to focus on here, which is sliding and slumping. 4 types of transportation: traction, saltation, suspension, solution, or trasal, sasol. And we're going to look at deposition, but the cause of deposition, although the processes involved require the river to lose energy, much like when a coast deposits its sediment, it's because it loses energy. The reason why energy is lost in the river will be different to that which occur at coasts. Now, although a lot of these are very familiar and very similar, there are some differences between rivers and coasts, which means that we can't just kind of change the word coast for river and it'll be all right. So not only the landforms you get as a result of these processes, but also some of the other forces working at play with regards to rivers, because at coasts, waves are the main or the dominant sort of movement, the erosive kind of agent when it comes to changing the coastline, whereas you don't get waves in rivers, or if you do, they're not significant enough because rivers aren't driven by the wind, whereas waves are. Rivers are driven by another force, gravity, and gravity will vary along the course of a river, but we're going to do that in another session. Okay, so today is just this recap of all these different physical river processes. We'll look at human ones again as well, but we're going to look at the physical processes in this session. So once you've got the title written down and got the resources from the Joglogs folder on 365, then we can begin. You can skip to the next slide. So as a bit of a recap from the last session, this is a drainage basin. You should be able to name A, B, C, D and E. Okay, so you should be able to name these parts of a river's drainage basin. Alright, so if you want to pause the screen and do that, that will be handy, and then after you've unpaused the screen, I'm going to reveal the answers. Okay, so you should be able to spot that A is a tributary, B is pointing specifically at the point where 2 rivers meet, so it's a confluence, C is at the start of a river, so that's probably the source, D is where the river meets the sea, so that's the mouth, or you could have put channel for that as well, and E on the red line is the watershed. Okay, so tributary, confluence, source, mouth or channel, and watershed. So hopefully those key terms are in there, and remember, key terms often form the very first questions of any part of a topic with like a multiple choice answer or just a simple define the term mouth or what part of a river meets the sea or wherever it might be. So this is where you'll need to write a few notes for your book, please. So river, just like coasts, the work of rivers or the things that rivers do involves 3 main physical processes, 3 main naturally occurring processes: erosion, transportation and deposition. So those 3 things are always working in the river at some point to some degree. But obviously which one dominates is very dependent on how much energy there is available. So where there is more energy available, erosion is more likely to be the dominant process, and also transportation too. When energy starts to decrease, it'll start to be more of a depositional river. So essentially a river dropping more sediment than is being kind of created. So energy is the key here, and whichever energy type or however much energy is present will determine how much erosion, transportation and deposition can take place. So there is a video which is saved on 365. It's pretty old school, to be honest with you. It's from quite some time ago, and if you want a better video, then you probably want to go onto the Time for Geography website. Now it's free, you sign up and they'll send you emails or whatever, but it's got loads and loads of different up-to-date, very modern and very well produced geography videos, which are specifically to help kind of illustrate processes in real terms. We don't have the the ability to get to every single thing that we teach you about in geography, and rivers are not very exciting when it comes to East Anglian rivers. We don't have like features like waterfalls and things like that. So learning about rivers remotely means that having a good quality video is useful. But if you do want to be lazy, you can just follow that YouTube link there, which I believe is saved on 365. But if it's not, get yourself on Time for Geography, search that, and then you'll see loads of good geography videos and hopefully be able to navigate your way through. So again, just a nice hint back towards the coast stuff, where you try to remember hydrabatsol, hydroc-action, abrasion, attrition, solution, and traction, saltation, suspension, solution, trisaltosol. And there'll be some obviously additional notes that you need to get down as well that are specific to rivers. Okay. So this is the first very specific to rivers section you need to be doing. Okay, so you've got different types of erosion within rivers, and by different types of erosion I don't mean the hydrabatsol, I don't mean the hydraulic action, etc. Those things happen. Okay, they are specific types of erosion within the channel, but the direction of erosion is what I'm really kind of more referring to here. So when it comes to rivers, they will either dominantly erode down, vertical erosion we call that, or they'll erode left and right, or laterally, horizontal erosion. They'll obviously do that to certain degrees at the same time, but whichever one dominates depends on where in the river you are. So remember, the force that's acting in rivers is predominantly gravity. Gravity is the thing that moves rivers from upstream to downstream. So when you drew your drainage basin, the source of the river is always at the highest point of that river's drainage basin, and then it flows downhill because gravity is the thing pulling it that way. And then when it reaches sea level, which effectively is zero, then it runs out of that gravitational potential energy. So the higher up you are, the greater your gravitational potential energy. And if you've got greater gravity pulling down at you, then you're going to get more vertical erosion the further away from sea level you are. So nearer the source, you'll have more vertical erosion. So write this down, please. Vertical erosion is a characteristic of the upper reaches of a river channel, where the land is high above sea level as the river is attempting to cut down to base level. So vertical erosion there. So pause the screen, make sure you get that definition written down, please. Now, vertical erosion explains why the features that have height, like waterfalls, for example, or the features that create tall features like V-shaped valleys or gorges, you find in the upper reaches of river, the further away from the source, nearest the source. So it's because the river is physically being pulled down by gravity, so erosion happens more vertically, and it creates these taller features that have a drop. In Norfolk, you might be aware that we don't have many hills. We certainly don't have much in the way of gravitational potential energy, and that's probably a reason why we don't have any particularly good waterfalls. Geology is another factor, but essentially there's very little gravitational potential energy. Our rivers are not torrents really in Norfolk. So as rivers get closer to sea level, get closer to their mouth, they get closer to zero. So because they get closer to zero, they've got less gravitational potential energy. So now they've got less force pulling them down, and so the power to erode is now really driven by the amount of water in the river channel itself, and that is horizontal or left to right lateral erosion. So that occurs more regularly in the middle and lower courses of a river, or lower parts of a river, where the valley and the floor of the river channel essentially lies closer to sea level, and that's all because of that reduced gravitational potential energy. So write that one down, and once you've written that one down, then I'll skip to the next slide. So that's the kind of difference between erosion in rivers compared to coasts, because at coasts everything is sea level. So the waves are at sea level already. The gravity has no impact on them whatsoever. So it's wind, the strength of the wind is what increases the rate of erosion of coasts. Whereas in rivers, wind's not a factor. It's now the dominance of the gravitational potential energy that makes a difference. So transportation in rivers, again, much like in coasts, is driven by the force or the energy a river has. If a river has a lot more energy, it can transport more and bigger bits. But the bigger the bit, the less likely it is to be able to pick it up. So it might roll or drag stuff along the river bed or the river channel bed, rather than pick it up. And that's called traction. We know that. We also know that obviously slightly smaller sediment can be picked up, but for short spells of time, and that's saltation, bouncing. Then some that's suspended in the flow is called suspension, or through suspension, and then you've got dissolved stuff from rock higher up in the river valley, and that's through solution. The word we use to describe the stuff in a river is called its load. So it's load, just like the load on a truck, okay, is the stuff it's carrying. A river's the same. So a river's load is what the river is carrying within its flow. So where it gets its load from makes sense, really. Any material that's been washed into the river or has fallen into the river from the valley sides, and that can be from things like mass movement events or a storm event or something like that, or weathering, or material that actually the river has managed to pick up itself from the riverbed and banks. So it's either already in the river and the river itself kind of picks it up, plucks it away, not plucks it away, but drags it away, or it's fallen into the river from the valley sides. Okay, that's where the load comes from. Now along the course of the river, that load bumps into other bits and gets smaller, smoother, more rounded. And again, another reason why you'll get smooth, smaller pebbles further downstream of a river, whereas the sediment tends to get smaller as well. It gets less angular, just like you might find at the coastline. Okay, so these, again, just a nice recap of the 4 types of transportation: traction, saltation, suspension, and solution. I'm not going to dwell on that. If you want to go over that in more detail, you can, but you need to go back to one of the coasts lessons where I give more time to define these particular transportation methods. So deposition in rivers. Now this is again something where there are differences, because the reasons why energy is lost in the river are different to the reasons why energy is lost at coasts. So a river will deposit when it's got less energy or not enough energy to carry or transport the load it's carrying, and that's normally because the river has less velocity or it's slowed down. Slower rivers have less energy, and which is something that was sensible, really. The heavier stuff is going to get dropped first. So if rivers have heavy material that they're trying to transport, the sooner the energy runs out, or the first time the energy runs below a certain amount, it will be the big stuff that can't be moved. The smaller stuff might still be able to go in the flow, but the bigger stuff won't be able to move. And then eventually, obviously, the less and less energy it gets, the smaller the load it can actually carry. So reasons why rivers lose energy. I'm going to tell you about those reasons straight away on the next slide. So once you've got the notes for this slide, unpause and I'll go through those reasons. Okay, so some nice images to help illustrate that. The top left one represents a river that's very shallow, it's very narrow, and it's got a lot of these things, big boulders, big lumps in it. So as the river travels down this very narrow, shallow river channel, it's really being met with a lot of friction. And as soon as it hits a big boulder, again, loads of friction. A good sign of friction in a river is where you can see white water. Okay, because essentially that's turbulence, and turbulence only happens with a river that's being like hit or stopped by some means. So friction with either large obstacles in the river or with the sides and the valley, sorry, the sides and the riverbed, etc., will make a difference. Okay, so that will create deposition because it's reducing the energy of the river, it's slowing it down. So that's one thing you need to write down. Another reason that rivers deposit and lose energy is when they go round a corner. So a river bend or a corner is called a meander, and you can see from this image that this river is meandering. Okay, it might be coming from this way actually, but it's meandering round here. Now the outside of the river bend doesn't have deposition. In fact, the opposite's happening. Erosion's taking place here. I will explain that in a later lesson. On the inside of the river bend, you can see, look, this is a big sand bank built up, or a sediment bank. This is called a point bar, sometimes called a slip-off slope. And this is built up, this is deposited material that's built up over time as the river has reduced its flow rate. So the inside of a bend is much slower than the outside of a bend. The outside, the water gets whipped round the outside in something called a thalweg. But essentially the inside is slower, and if it's slower, less velocity, less energy, it'll deposit stuff. Another reason the river deposits its load is if it floods. As soon as a river bursts its banks, it spreads out over a wide, very shallow distance, which creates massive friction, and that friction means that anything the river might be carrying outside the flood will just get deposited. And then lastly, you can see a river here meeting the sea. As a river meets the sea, you've got waves coming in, the flow of the river going out, and they kind of, one force meets another force and they nullify each other, so to speak. And so as a result, you get sometimes ridges of sediment that's not just being deposited from the sea, but also being deposited on the other side by rivers. And that can often create something like a salt marsh, or even a lagoon, depending on where you are. But effectively, if a river's coming out, you're not going to get a lagoon, you'll get a salt marsh. And so your big plants like marsh samphire in this country can grow, and other species that are really good for birds and things like that. Okay, and now a few more notes on mass movement. So exactly like coasts, mass movement, the definition, the movement of rocks and soil downslope due to gravity, just like they are at coasts. You know, they travel down from the top of the cliff to the bottom. And it can involve lots of stuff, it can involve little bits of stuff, but effectively it happens suddenly. It's generally very sudden or rapid. So there are three types. I know I mentioned two, slides and flows and things like that, and slumps happen too. You can see slumping going on here in this image. But something called soil creep also happens there. You don't need to know much more than just the basics of the three types of mass movement in rivers. And as these the soil creeps down the slope, or landslides or slumps into it, or rocks, even like rockfall, can still occur in rivers as well. It'll get into the river, and the river will pick it up and carry it downstream, and that will take that sediment away. So this is one of the contributing factors for rivers' load as well. So again, get the notes from this slide, and when you're finished with those notes, you can unpause the screen. Okay, and weathering, no different to the weathering you might see at coasts. It's all the same process, it's just happening in a river valley rather than at the coastline. So as a recap, you've got mechanical weathering, or freeze thaw would be our example of that. Chemical weathering, something like acid rain, or the acidic rain generally, or biological weathering, anything involving living stuff, so plants or animals burrowing and roots and things like that. Now, if you want to get this jotted down, that's absolutely fine, but on 365, I hope it's there, and if it's not, you're going to need to copy this. This is a mind map which summarises, for both rivers and coasts, so both of them, these different types of physical process which you need to be aware of and using when it comes to your landforms. Now, we haven't done landforms for rivers yet, but for landforms for coasts, we mean like cliff, wave cut platform, bay and headland, cave arch stack stump, spit, bars. Okay, all of those landforms you find at coasts can be explained with maybe 2, 3, sometimes even 4 or 5 of these different physical factors. So for example, You get bay and headland when you've got a discordant coastline, because you've got different geologies lined up. You get differential erosion. What type of erosion? Well, hydraulic action and abrasion. So these two things combine to create bay and headland. And in the bay, the headlands that have been created shelter the waves, so reduce the wind, and therefore lead to deposition, which puts sediment inside the bay, and you get what's called a bay head beach. So you've got erosion, deposition, and geological structure, as well as geological type, all working together to create a bay and headland landform. Cave arch stack stump, you've got again, you have to have a discordant coast because you have to create a headland to start with, and you've got erosion attacking both sides of the headland. You might have weathering that occurs to weaken the top of the arch before it collapses, again root penetration, biological weathering. Mass movement events occur then because the top is weakened and it will fall by maybe rock fall into the sea, leaving behind an isolated stack, which can support its own weight because it's hard geology. So you can see, look, how all of these things can combine together to create a landform. And what I really want you to take from this is that actually any landform, you need to say more than just one process that's made it, because more than one process has made it. When it comes to rivers, we're going to look at meanders, we'll look at waterfalls, we'll look at oxbow lakes, and all the same kind of processes could be useful to explain how those were produced. Now this is a really useful slide, and if you haven't, like I say, if it's not saved on 365 for you, get it copied down now while I'm, once I've finished talking, because this will be a really good guideline to you to just refer to for the 8 mark questions that we can get in this particular topic of this, this particular part of the paper. The 8 mark questions, I'll explain a bit more about those soon, but effectively what's really key is that the 8 mark questions are going to be examine questions. Now to examine as a command, okay, it requires you to look at the different component parts of something to see how they work together. So when it comes to coasts and rivers, one of the questions that's occurred now twice already in just 3 years of this being an exam board, a specification, 2 of the 3 have been examine the processes which created the landform shown. So they might show you a picture of a spit, or they might show you a picture of a cliff and wave cut platform, or whatever it might be. And if you've got to examine the processes which created it, you're looking at the different types of processes that created that feature. So you can look at deposition, you can look at erosion, you can look at whatever it might be. You can basically pick 3, 4 of these to help you explain and then talk about how these things work together in sequence or collectively to create that cliff and wave cut platform or that bay and headland. So that's really, really important, and I would use this as a revision thing as well. So you might want to practice using at least 3 to help you work out if you could answer examine questions. And if you want some even more guidance, and I would urge you to do that, get onto the revision playlist and look at the 8 markers made easy section, because that will talk you through with examples and color coded everything how to formulate each kind of paragraph for an examine question. It deals with all the 8 markers: examine, assess and evaluate, but it starts with examine, and this is the only topic. So paper 1, topic A, this is the only topic where you are going to have examine questions as an 8 marker, and you're going to have 2 of them. There'll be 1 for rivers, 1 for coasts. So this slide plus that video, really good preparation for you. Okay, I'm going to move on now because you're going to get very bored very quickly. So essentially that summarizes really the importance of this session. I really don't want you to leave this without knowing how important it is to know more than one process, because it's that common potential exam question, and if it's an 8 marker, it's worth a good chunk of the marks. Okay, so that is that session finished. Thank you very much for listening, and next time we're going to be looking at lesson 3 of rivers. Thank you for listening. Cheerio.